In this lesson, we'll be talking about congruent figures. At the end of the lesson, you should be able to recognize and indicate that figures are congruent and use transformations to confirm which preserve congruence. Corresponding sides and angles. Sides and angles, that means that they're sides and angles that match up. So the slash marks mean that the sides are the same length. We might not know what the size is, but we know they're the same. The arcs, the number of arcs, 1, 2, or 3, mean that the angles are the same degree. We don't know what the angle degree is, but we know, for example, in this one, that Y and Q are the same. So to check for congruency, we want to make sure that the corresponding side lengths and the angles are equal. So when you have a reflection, a rotation, or a translation, these transformations do preserve congruency, which means that they don't change sides. They just reflect over, they rotate around, they just slide, but they don't get any bigger or smaller. Dilations do not preserve congruency because they do get bigger or smaller, whether it's an enlargement or a reduction. A congruency statement means that you're telling that the objects are congruent. So you have to list the vertices in the same order and then use the congruent symbol. So if we have these two triangles, they look slightly different. So in order to write a congruency statement, it might be easier if we turn that around so that it's the same direction. So then I would say triangle HJI is congruent to NMO. So they have to be in the same order. So for example, I have these two triangles and I want to match each vertex of the first shape to its corresponding vertex in the second shape so that our sides and angles match up. So this first one, you see the triangle's kind of an odd direction here. So I might want to flip it over and turn it around so that I have the angles that are the same, pointing in the same direction. So now this makes it pretty easy because I can see that side AB is congruent to side DE, and side BC is congruent to EF. Notice that the order is the same. And side CA is congruent to FD. And I can see, according to the arcs, that side A, angle A, is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. So if I find the perimeter and area of each area, if I look at the rectangle, my perimeter is 3 plus 12 plus 3 plus 12, which is 30 centimeters. And the area of a rectangle is length times width, so that's 3 times 12. The perimeter of the parallelogram, the side here is 5. So I'm going to do 5 plus 12 plus 5 plus 12. My area is base times height. So my area is the same. So if two shapes have the same area, must the shapes be congruent? Well, here I've got two shapes. They're definitely not congruent, but they do have the same area. If two shapes have the same area, do they have the same perimeter? Well, no, these two have the same area, but different perimeters. So the point here is that we can't just look at perimeter and area to decide if a figure is congruent or not. We actually have to match up the sides and match up the angles. So in this one, if I want to select the corresponding angles, I can look and see here that M does not go with X. M is 30 degrees and X is 90. M does not go with V. M is 30, V is 60. M does not go with K, 30 and 60. M does go with W. M is 30 and W is 30. So if I want to write a congruency statement, again I have to write it in the same order. So M, L, K does not go with X, W, V because X is here, then W, then V. It does not go with V, W, X. It's going backwards. It does not go with VXW because over here L is in the middle, so we need X in the middle, but these two are switched up. So it does go with WXV. So how do we indicate that sides are congruent? We have the same number of slash marks. How do we indicate that angles are congruent? The same number of arcs.